So one other thing that I want to discuss in passing before we get into the meat of our power supplies is our primary power sources. And so if we think about our simple diagram that we've looked at in previous videos with sort of our box that's our power supply, we're talking about what things are giving us power on our left side. So where is our PN coming from? And so of course the answer is there are several different places that can be coming from. So one place that we can have this coming from is batteries. Another one, which is what we're going to focus on here, is AC utility lines. So this is going to be our focus. And we could also talk about renewables. So in terms of renewables, that would include everything like wind, solar, various types of energy harvesters, all of these different types of things. And which type of primary power supply we're talking about is going to depend on what type of power electronics we have. So remember, we can be doing DC to DC conversion, AC to DC conversion. We have all these different types of conversion that we can be doing. But again, we're going to focus on our AC utility line. So I just want to briefly talk about what the wiring for our single phase service looks like. And so hopefully this is just a review, but I want to make sure that we're all on the same page here. Wiring for our single phase. And so of course in most places here in the US, our power is delivered it's transmitted in three phase, but once it comes to our house or our business, once we have it at the outlet, in most cases, for most appliances, that's just single phase. And so what our wiring looks like for that is something like this. So let's paste this guy in here. So we have something like this. So again, this is just for one phase. So we know we have this one VAC source. We then have a hot line, which is the positive side of that. The negative side of that is our neutral or return line. And then we also have some resistance between our neutral line and ground, which is connected to an earth ground. So at least here in the US, we have some color conventions for these lines. So we have our hot line is typically going to be black. Our neutral line is going to be white. And then our ground is going to be either green, or sometimes you'll also see bare copper. And so the point of bringing this up is that it's usually good practice to use these colors if you're wiring anything connected to AC power. So use these colors when connected to AC power or when using AC power. That way, if somebody sees these three color combinations near one another, they can immediately know that this is a single phase AC voltage. And so for example, you could see in the test stands that we used in our control systems class, the power coming from our outlet has been wired with these colors in mind. Of course, anytime we're dealing with this 120 volt AC here in the US, we want to consider safety. So safety is of course always important, and this is going to be relevant for any design connected to AC. Sort of two facets of that. Of course, we're worried about electrocuting ourselves, so we want to consider our electrocution hazards when we're designing this. And so typically that's going to mean we want to power things off as we're working on it at the very least, but also we want to design in mind to minimize the chance for electrocution. And we also want to be thinking about overcurrent protection to protect some of our more sensitive parts of our circuit. And so that can often take the form of a fuse or a circuit breaker. So things like that are typically good design practices. So here we've talked about the single phase service, but like I said, power, at least in the US, is primarily transmitted with three-phase AC. There are some appliances in homes and of course a lot of things in industrial spaces that will use three-phase power. And so typically we're going to do that when our standalone load is using more than about 2 to 5 kilowatts. So standalone loads greater than about 2 to 5 kilowatts means that we're going to use three-phase power. And so the reason we want to use three-phase power is that we can reduce our conductor size. So if we were trying to pull that much power from just one phase, we'd have to have a much larger conductor, which of course means a lot more expensive.